A 40 kg block is moving to the right hand side with a speed of 1.5 meter per second. When it is acted upon by the two forces F1 and F2, we have to calculate the velocity of the block after 12 seconds. If you see the free body diagram of this block, the F1 acts in the right hand side direction, the same F1 will act in this direction, and F1 will act in this direction, and the same F1 will act in this direction if the string remains same. So the total force acting on the block due to F1 will be 4 times F1 in the right hand side direction. Okay, that will be the total force due to F1. If you see the force F2, it is the force F2 will act in this direction for the block. So F2 is acting in the left hand side direction. So if you calculate the resultant force, let us assume that the block goes in the right hand side direction. I do not know the value, but let us assume the block goes in the right hand side direction. So the resultant force will be equal to F1 minus F2. Okay, or I can say that it will be equal to 4F1 minus the F2. Okay, so now I got the resultant force. Let us calculate the impulse over here. The impulse will be given as integration of f dt. Okay, now why I am calculating impulse? If I write down the formula of impulse, it will be equal to mv minus u. Okay, I know the mass, I know the initial velocity, I have to calculate the final velocity. I can say that it is 4 times f1 dt plus integration of f2 dt. Okay, it will be integration of f2 dt. So let us first calculate the area under the graph. The integration is the area under the graph for f1. If I calculate for f1, it is forming a rectangle over here which is 4 into 30. Okay, which is equal to 4 into 30, which is equal to 120, and there will be another block formed over here which is equal to 2 into 10. Okay, 4 into 30, which is equal to 120. This will give me the answer 120 plus 20, which is equal to 140. So basically it can be written as 4 times 140 minus, it will be minus, not plus. Okay, it will be minus. If I calculate the value over here, f2 for integration of f dt, f2 dt, it will be area under the graph. We will use the same procedure over here to calculate the area under the graph. Okay, so basically if I calculate the area under the graph, a small rectangle is formed over here whose area is equal to 20. This will be equal to 20 into 2, which is equal to 40. So 20 plus 40 is equal to 60. This will be equal to 40 into 2, which is equal to 80, which is equal to 80 plus 60, which is equal to 140. So which is equal to 140. So it will be equal to 140 into 3. Okay, I will keep it as it is. Okay, now the mass over here, this is equal to m v minus u. The mass over here is given as 40. Final velocity, I do not know the value. Initial velocity is 1.5. Okay, so v minus 1.5 will be equal to 140 divided by 40, which is equal to 14 by 4, which is equal to 14 by 4 will be equal to 3.5 into 3. Okay, so basically v will be equal to 3.5 into 3 will be equal to 10.5 plus 1.5. So 10.5 plus 1.5, the final velocity will be equal to 12 meter per second. Okay, the final velocity of the block of 40 kg will be equal to 12 meter per second.